Hearty welcome once again to the Math Revision Made Meticulous video series. Topic matrices. Under this topic we will see an operation on matrices. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answers. Let us see what do you mean by addition of matrices. Two given matrices A and B can be added if both A and B are of same order. The sum of the two given matrices is obtained by adding the corresponding elements of the given matrices. Suppose if you take A, capital A as Aij, B as Bij are the two given matrices of the same order M cross N, then the sum C is equal to A plus B is the matrix C Cij of order M cross N, where Cij is Aij plus Bij. Corresponding elements are added. That's all. Let us take one example now. I am just simply adding them. The elements are added: 1 minus 9, 2 plus 3, then 4 plus 8, minus 1 plus 0, 2 minus 3 or 3 minus 3 plus 2, 6 plus root 2, and you are getting the answer. Under multiplication, if Aij, matrix A is element of Aij is a given matrix of order M cross N and K is a scalar, then Ka is a matrix obtained by multiplying each element of A by K. That is, we are going to multiply by a scalar. If you multiply by a scalar, every element will get multiplied. That's all. That is the meaning. Suppose I take A as 3, 4, 2 minus 1. If I want to multiply it with the 2, I have to multiply the 2 with every element. 3 into 2, 4 into 2, 2 into 2, minus 1 into 2, you will get the answer. This is called scalar multiple of a matrix. In the same way, suppose if you see an element common in all the elements, you can take it out also. Okay. Now, properties of scalar multiplication are, there are two scalars, then K into A plus B is Ka plus Kb, K plus L into A is Ka plus La. Now let us go to negative of a matrix is denoted by minus A and it is multiplied by minus, that's all. All the elements are multiplied by minus 1 is called negative of a matrix. When you go to difference, it is very simple. As we have added, we are going to find the difference. And suppose if you want to find A minus B, you are simply subtracting the corresponding element. 1 minus of minus 9, 2 minus 3, 4 minus 8, minus 1 minus 0, minus 3 minus 2, and 6 minus root 2. Then matrix addition property is commutative law. A plus B is same as B plus A, and A plus B plus C is same as A plus B plus C. Then matrix addition, there is one identity is there in matrix addition. Suppose when you add a matrix of order M cross N and 0 matrix is also an order of M cross N, when you add it, you will get back A. Then if you add two matrices and if you get a 0 matrix, both are called additive inverse to each other. Then let us go back to the next interesting idea, that is important one, multiplication. The product of two matrices is defined if the number of columns of first matrix A is equal to number of rows of the second matrix B. Suppose if you take M cross N is the order of the first and M cross P is the order of the second, then the order of the product will be M cross P. To get the element, we take ith row of A and kth row of B and multiply them element wise and take the sum of this product. Let's take one example and check out now. Now it will be like this, and A is order 2 cross 2, B is order 2 cross 3. Therefore, number of rows, columns of A is equal to number of rows of B, and C will be A into B, which is order 2 cross 3, and its elements will be A11, A12, A13, A21, A22, A23. Here only you have to be very careful. A11 will be obtained by taking first row of the first matrix with the first column of the second matrix and operate. A12 means first row of the first matrix with the second column of the second matrix. Operated and added. A13 means first row of the first matrix with the third column of the second matrix. Similarly, at random, when I want to tell A23, second row of the first matrix operated with the third column of the second matrix. It's very simple. Therefore, row of the first will be added, operated with the column of the second. Well, now let us see one idea how to do it. A1 is obtained by multiplying elements of row 1 with the elements of column 1. A12 elements of row 1 with the elements of column 2. A13 elements of row 1 of A with the elements of column 3 of B. Similarly, A21 multiplying and adding the elements of row 2 with the elements of column 1. A22 elements of row 2 of A with the elements of column 2 of B. A23 multiplying and adding elements of row 2 with the elements of column of 3 of B. Now let us see visually how it is being done. Now I have taken AB, I have written them. First row to be multiplied with the first column. Then how to get it? Then first row with the second column, first row with the third column. How I got the numbers? 1 into minus 2 plus 2 into 4. Again 1 into 3 plus 2 into 5. 1 into 1 plus 2 into 6. Similarly, the second row to be operated with the first column, second column and third column. 4 into 2. So 4 into minus 2 plus 6 into 4. 4 into 3 plus 6 into 5. 4 into 1 plus 6 into 6. Simple, add them and give the final matrix as C is equal to 6, 13, 13, 16, 42 and 40. Properties, associative law, A, B, C is same as A into B, C. Distributive law, suppose you have two matrices which are all to be multiplied. A into B plus C is AB plus BC, wherever product of both sides are defined. Then multiplicative identity is there. Suppose if you have A, I is the identity, A into I is same as A. Okay, this is the property of multiplication of the matrices. But multiplication of matrices is not commutative. AB is not equal to BA. Sometimes BA may not be defined. If BA is defined also, if both A and AB and BB are defined also, they will not be equal. Well, let us go to some questions for revision. Suppose it is given that X into a matrix plus Y into a matrix is equal to 10, 5. You have to find the values of X and Y. Now, this is the first one is nothing but scalar multiple. Therefore, I am doing scalar multiple. Second is also scalar multiple. In the left hand side, two matrices are to be added. The corresponding terms are added up. And I am equating, because when two matrices are equal, corresponding elements are equal. 2x minus y is same as 10 and 3x plus y is same as 5. I am adding the equation. I am getting 5x is equal to 15 and x is equal to 3. When I substitute x is equal to 3 in another equation, I am getting y is equal to minus 4. Therefore, we have solved the equation by getting the values of x and y. Let us go to the next question. This is actually a question where we have to use the properties of trigonometry. A function is given as cos x minus sin x 0, sin x cos x 0, 0, 0, 1. We have to show that f of x plus y is equal to f of x into f of y. You know what is the meaning of f of x plus y? Wherever x comes, it should be replaced by x plus y. F of y means cos y minus sin y and so on. Well, now let us know what to do is, let us first find what is f of x. Let us write what is f of y. Let us try to find the right hand side. That is f of x into f of y. It is normal multiplication. All of you know how to do. First row operated with the first column. Cos x cos y minus sin x sin y plus 0. Again first row operated with the second column. Minus cos x sin y minus sin x cos y plus 0. First row operated with the third column. 0 plus 0 plus 0. Similarly, second row operated, you got the second rows. Third row operated with the columns, you got the third row. And you got it as, the formula looks like sin x plus y and the formula looks like cos x plus y. Therefore, I am replacing it as cos x cos y minus sin x sin y by cos x plus y. Minus, by taking minus sign outside, the second term will become cos x sin y plus sin x cos y, which is minus of sin x plus y. Similarly, sin x cos y plus cos x sin x is sin x plus y. Cos x cos y minus sin x sin y is cos x plus y. Therefore, it is f of x plus y. Therefore, you got the idea that f of x plus y is same as f of x into f of y. It happens because of the trigonometric conditions. Well, let us go to the next question. This is a question where you have to form a equation. These equations are called characteristic equations of a matrix. And from this equation, we can get A inverse also. We will do later. But we have to simply prove it. Very simple. Find A square, find A cube, find A, put it in the equation. But remember, this I which is there, it will be either a identity matrix of order 2 or 3 accordingly. If A is given as order 3, I also will be of order 3. Well, 3 cross 3. A square I am getting. Very simple. First row operated with the first column. First row operated with the second column. First row operated with the third column gives me the elements of the first row. Similarly, second row operated with the first. Second and third give me the second row. Third row of the first matrix operated with the first, second and third columns of the second give me the third row elements. For I got A square like this. What is A cube? Once again you got to multiply with A. The same thing I am doing once again. Therefore I got the answer as 21,034, 12,823 and 34,055. Now I have to go to the equation now. What is the equation now? A cube minus 6A square plus 7A plus 2A. I am putting it there. Now in minus 6, 7 and 2 they are all nothing but scalar multiples. Bring them inside. And all the matrices are of same order. Therefore we have to add them. I am adding and then subtracting. Therefore these are to be subtracted and I am getting every element as 0. Therefore the answer is 0. Remember, this is a matrix equation. Therefore on the right hand side 0 means 0 matrix. Let us go to question number 4. You have been given A and B and we have been given A plus B whole square is equal to A square plus B square. Normally it cannot be. A plus B whole square is A square plus 2AB plus B square. Anyway, this is A plus B whole square. Matrix addition and squaring is square of the first matrix plus square of the second matrix. And you have to get the value of A and B. Very simple. Now what we will do is we will find expansion. It will become A square plus AB plus BA plus B square. All of you know, but be careful. This AB and BA are not equal. Don't directly write it as 2AB. It cannot be possible in matrices. Well, now it has been given that A plus B whole square is A square plus B square. Therefore I am putting it in the left hand side. For A square plus B square is equal to A square plus AB plus BA plus B square. What will happen? A square will get cancelled. B square will get cancelled. Therefore you are getting AB plus BA is equal to 0. AB plus BA is 0. That is why you are getting A plus B whole square as A square plus B square. Now let us take this equation now. Let us find what is AB. This is AB now. Normal multiplication. Now let me find what is BA. Again 2 cross 2 with the 2 cross 2. Now I want that A plus AB plus BA is 0. Just now I have derived it. I am putting it in the equation. Now I am adding them. Now you can equate the corresponding terms. For when I equate, I am getting 1 minus A is equal to 0. When I equate it, I am getting 4 minus B is equal to 0. When I solve it, I get A is equal to 1 and B is equal to 4. For here, I have used the idea that A plus B whole square is A square plus B square, so that AB plus BA is equal to 0. Where A is equal to 1 and B is equal to 4 satisfy all the equations. You can check it out also. Let us go to the next question, where you have to find the matrix A such that the product of these two matrices is equal to, matrix 1 into A is equal to the other matrix. Here it is not mentioned about the order of A. You have to find out what is the order of A. Further, how to find out? Very simple. Now what is the order of first matrix? It is 3 cross 2, where you are getting 3 cross 2 as the final answer. For what should be the order of A? Order of A should be 2 cross 2. Then only you will get 3 cross 2 as the final answer. For all of you know, if it is a 2 cross 2, how to take it as A, B, C, D. Very simple. Now therefore I am putting it as product now. I know how to do the product now. First row operated with the first column. First row operated with the second column. Again first row with the first column. Second row with the first. Second row with the second. Again third row operated with the first column. Third row operated with the second column. Now I got a 3 cross 2 in the left hand side, 3 cross 2 on the right hand side. Equate them and you will get equations now. And solving those equations, I am getting the value of A 1, B is equal to minus 2, C is equal to minus 3 and D is equal to 4. In this problem, product is given, but the order you have to find. You have to find the order, then you can solve the problem. Well, thank you. Success is dependent on efforts. All the best.